Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapience Education. So today I am going to discuss about the atom chapter. So here we go. So let me discuss about the first concept which has come up, that is Rutherford alpha alpha particle alpha particles scattering experiment by the Rutherford. So Rutherford, a scientist who renowned scientist who has done some of sort of the experiment in which he able to do an experiment in 1911, and in this figure you will find that this is a radioactive substance, right? And from this radioactive substance, alpha radiation happens, alpha rays came out, and there is a thin gold like structure, and thin means very thin. It is about 10 to the power minus 8 meter thick, so which is very thick, thin, and it is approximately about a single atom only thickness. Okay, so he has done some sort of experiment, and this you can say that, see that this is a microscope detector. Whenever alpha particle will just see back and come in this direction, so this instrument will detect itself. And this is a zinc sulfide screen, and in zinc sulfide screen, what is the work of the zinc sulfide screen? Whenever alpha particle will strike, so it will start glowing. So this is the work for the zinc sulfide screen, right? Now, mm, let us observe this experiment done by the Rutherford, right? See, this is the rays. So see, this is an alpha rays is scattering. So this rays come out, and this is a gold foil. You can see that this is a gold foil, and what happens? Some of the electrons. See, this is your radioactive source from where alpha rays will come out. So from this portion alpha will be come out. Alpha means approximately helium mass. It has a helium mass where it has 2 proton and 2 neutron. So that will be considered as a alpha particle. Now see, this is the gold foil, and this is the thin gold foil, and it is circulated by zinc sulfide, right? So from here you can understand, and this is the slit, right? This is the slit from where alpha rays will go. So see, this is the things. Okay, so from here you can observe that how these behaviors come out. See, most of the particles pass thoroughly. Some of them are got scattered, right? Deflected at certain angle, and very few return back at this same angle, right? At the same direction. So that is, so from this detection happens. See, whenever alpha rays strikes in the zinc sulfide, it will start blinking. So this is the detection method. So what are the observation? So observation, it has been observed that observation one, that most of the particles passes thoroughly. See, this is your first observation, right? And we need to understand what is second observation. Second observation, see, some of the particle got at a certain angle, it has been deflected. So this is our second experiment. Some of the alpha particle were deflected by the foil by the small angle. Now this is the third observation. Out of 12,000, only one come back in the same direction. See, same direction, that is 180-degree movement or 180-degree back. Surprisingly, you can observe this, what is happening. This is the atom. See, this is what actually happens, right? So this is an atom, so this is what actually happens, and most of the particle pass thoroughly, right? See, so I hope you have understood this. So conclusion 3, see, conclusion 2, it is some of the particles got deflected, and this is conclusion 3. See, some particle come by back. Now I will discuss this in see observation. So first observation is that Rutherford made the following observation from the experiment. Most of the alpha particle passed through the gold foil without any applicable deflection. Okay, that is uh, 0 degree at 0 degree angle. So about 10 to the power 7 particles. Only 0.14% of the alpha particle is scattered by more than 1 degree angle. So as soon as 1 degree angle, only few particles got deflected. About alpha particle in every 8000 alpha particle deflected by more than 90 degree. About one right. About one alpha particle in every 8000 will get deflected by 90 degree. The total number of alpha particles is scattered through an angle theta as shown in a figure. So from this you can see that as soon as angle will increase, so number of particles get scattered will be decrease, right? So the number of alpha particle is scattered per unit area that is n theta at a scattering light angle that is theta varies inversely to theta by 2. So from here we can observe that, or it has been observed that the number of scattering particle n about an angle theta is proportional to the 1 by sine of 4 times of the theta by 2. The force between the alpha particles and the nucleus is given by 1 by 4 pi epsilon naught 2 pi z by r square, where 2 electron means charge of the electron, z means uh, mass number, and it is E, where r is the distance of the alpha particle and the force directed along the line of joining the alpha particle and the nucleus, and the magnitude and the direction of this force on a alpha particle continuously changes as each approaches the nucleus and recedes away from it, right? Now conclusion. On the basis of this conclusion of his experiment, Rutherford concluded that the atom has a lot of empty space. So we have observed that most of the alpha particle pass thoroughly without any deviation. So we can say that there was an empty particle. Practically the entire mass of the atom is confined to an extremely small central core is called nucleus. Definitely only few are coming out. It means that most of the mass are concentrated at this place, so that the whatever we are sending the alpha particle, it re come this side, whose size is the order of 10 power minus 15 to 10 power minus 14. Scattering of alpha particle positively charged is due to the Coulomb's law of electrostatic force of repulsion. Now let us try to understand these things. So let us consider this is a positive charge, right? Or this is a nucleus, and this is an atom, and as we know that the alpha particle is positive charge, right? Alpha particle is the positively charged particle. Now here, from here we can say that it is due to the Coulomb's law of electrostatic force, the repulsion between positive charge of the nucleus and alpha particles happens. So what will happen, as soon as this alpha particle will approach at this point, so what will happen, this is positive charge, alpha particle is also positive charge, so repulsion will happen due to the electrostatic repulsion force. Next is distance between the electron and the nucleus is of the order of 10 to the power 4 to the power 10 to the power 5 times the size of the nucleus. So it means that the distance is very large as the size of the nucleus. So nucleus size is very teeny and the atom size are very large. More is the distance of the velocity vector of an alpha particle from the central line, the nucleus, lesser is the angle of its scattering. So how to understand this? You need to understand. See, let us consider this is an atom, right? A nucleus, and this is whole as an atom. We can say that this is an atom, and there is a yellow light. So see here, as soon as it passes thoroughly, so the angle of deviation will be very large, or it will be more bit larger. It will be a bit larger. So let us again do it. So this alpha like this. Again, as soon as the distance between the alpha particle and this one will increase, so what will happen? Angle will decrease. Angle will decrease like this. See, and finally it will become 0. So it means that the more the distance, lesser is the more the distance of the alpha particle from the positive charge, so lesser will be the angle of deviation, right? So the more is the distance of the velocity vector of an alpha particle from the central line, the nucleus, the lesser is the angle of scattering. Now next is Rutherford's model of atom. So he has proposed model of the atom. Essential feature of the Rutherford's nuclear model of atom planetary model of the atom are as follows. Every atom is consist of central core called the atomic nucleus, in which the entire positive charge or almost entire mass of the atoms are concentrated. Let us consider this is the central part and it is considered as a nucleus, and most of the positive charge, that is proton and neutron, are confined at this point only. The size of the nucleus, next is your size of the nucleus is of the order of 10 power minus 15 meter, which is very small as compared to the size of the atom. So if you think that size of the atom as per the comparison of the size of the nucleus is very large. So this is the second observation or conclusion given by the Rutherford. Now, atomic nucleus is surrounded by a certain number of electron. An atom is as a whole is electrically neutral, and the total negative charge of the electron is surrounded by the nucleus is equal to total positive charge of the nucleus. Now, let us consider there is a neutron, there is a proton, right? So, if there is a 10 proton, so definitely there will be a 10 electron here, 10 electron around it, right? So, it means that overall, if you observe that number of electron will be equal to number of proton, and this whole atom will be electrically neutral, right? Neutral. Next, the electron revolve around the nucleus in a various circular orbit as the planet do around the sun. The centripetal force required by the electrons for the revolution is provided by the electrostatic force. You know that wherever you will observe that wherever there is a circular motion, let us consider this is a nucleus, neutron and proton, and as a whole electron is revolving around this. So what will happen? It requires of some force so that it will remain in a circular orbit. So which type of force is required? Centripetal force. Centripetal force in a circular motion. So from the centripetal force, petal force. Now from where this centripetal force will come out? So we need to understand that centripetal force will be come from this electrostatic charge, that is k q1 q2 by r square. This is the electrostatic force, and this will be this force will only provide the centripetal required centripetal force for the circular motion, right? The electron revolve around the nucleus in a various circular orbit as the planet do around the sun. The centripetal force required by the electron for the revolution is provided by electrostatic force of the attraction between the electron and the nucleus. Now let us understand what is distance of the approach. Distance of the close approach. As the alpha particle approaches the nucleus, the electrostatic force of repulsion due to the nucleus increases, and the kinetic energy of the alpha particle goes on converting into the electrostatic potential energy. At a certain distance r0 from the nucleus, the whole kinetic energy of the alpha particle converts into the electrostatic potential energy, and the alpha particle cannot go further close to the nucleus. This is called the distance of the closest approach. Now let us consider this is your nucleus, and this is an atom, and let us consider alpha particle is moving right around it. So alpha particle is moving around it, so it has some of the energy that is considered as a kinetic energy. What will happen? Its kinetic energy will get converted into potential energy between these two, positive charge and negative charge. That is positive charge and this is positive charge, so not negative charge, positive charge. So what will happen? This will become slow as due to the repulsive force, right? So there will be a repulsive force between this positive charge as well as nucleus, right? So as soon as it will approach nearby, so it will at one time it will stop. It won't able to go further because Let us consider it has a kinetic energy of 100 joule, and at this point this kinetic energy can get converted into potential energy due to the electrostatic force. So finally it won't able to go further, and this distance is called the distance of the closest approach. This distance that is considered as the distance of the closest approach, r naught. Now at this distance closest approach, this is distance of the closest approach. So kinetic energy of the alpha particle is equal to electrostatic potential energy. Why? Because whatever the kinetic energy of the alpha particle was there, so it has been converted into the electrostatic potential energy. So from here we can say that the kinetic energy is equal to 1 by 4 pi epsilon naught Jd, that is Z is number of proton and neutron, into 2e divided by r naught. So the charge of an alpha particle is plus 2e, and the charge on the nucleus is Ze, that is Z is the number of atomic number. So from here what we have got, try to understand that kinetic energy is that is equal to potential energy, because this kinetic energy got converted into potential energy. And how you will find the potential energy? That is equal to k q1 q2 by r square. Sorry, k q1 q2 by r. So this is the formula for the potential energy, where r is the distance of the closest approach. Why? Because at this point you will get the potential energy, so this the distance between this will become r naught. So from here r naught we will get, you just need to put the values, that is equal to 1 by 4 pi epsilon naught into q naught means Ze into 2e, that is the charge of the hydrogen, or sorry, helium alpha particle, divided by r naught, and this is equal to kinetic energy. From this, what we have observed, from this we can write this r naught as 1 by 4 pi epsilon naught into 2 Ze square by k. Now you know that kinetic energy is equal to half into mass into velocity square. So this is very important. So this is what all about the kinetic energy. So I hope you have understood this. So now, next is angle of scattering. Angle by which the alpha particle gets deviated from its original path around the nucleus is called angle of scattering. Let us consider there is a nucleus, right? And an alpha particle is try to travel like this, right? So but due to the repulsive force, it again bent in this direction. So the angle moved by this is considered as the angle of scattering. This is considered as the angle of scattering, right? Now the impact parameter. What is impact parameter? A perpendicular distance of the velocity vector alpha particle and from the central line and the nucleus of the atom is called the impact parameter. So let us consider what is the central line. So definitely this is the central line, right? This is the central line, and this is the impact parameter, and it has been written as b. B is considered as the impact parameter, right? Impact parameter. Now from here we can find impact. Mathematically it has been now expressed as impact parameter as 1 by 4 pi epsilon naught into Z, that is atomic number, into E square into cot theta by 2, that is angle of scattering, divided by kinetic energy. And kinetic energy can also be written as half mv square. So you can use these formulas to get this, right? I hope you have understood this. Now the very important thing, in case of a head-on collision means directly alpha particle will strike to the target. The impact parameter is minimum, that is alpha particle rebounds back. Why impact parameter is minimum? See, whenever alpha particle will be in head-on collision. Head-on collision means what? The distance between central line as well as this alpha particle rays is 0 or less than 0, then only there will be a head-on collision. Head-on collision means it will come re-back in the uh, same path, right? So from here we can understand that we can from there here we can understand that the trajectory of alpha particle in a Coulomb field of the target nucleus, the impact parameter and scattering angles are also depicted. See here, impact parameter will be 0. Why? Because whenever alpha particle hit directly the target particle, so it will again came in the same direction, the rebound in the same direction. So that is why impact parameter will be 0. So I hope you have understood this impact parameter. Now let us consider electron orbits, right? The Rutherford nuclear model of the atom pictures as the atoms are electrically neutral. A sphere consists of a very small and massive positively charged nucleus at the center, surrounded by the revolving around. Okay, so what will happen? Let us draw this. So this is the entire atom, and there is a small nucleus which is very tiny, and the electrons are there, protons are there. So what will happen? There will be an electrostatic force of attraction between the revolving electrons and the nucleus, provide the requisite centripetal force. So centripetal force will be provided by basically electrostatic force, right? So from here what we can say that centripetal force Fc is equal to electrostatic force Fe. Now if any body is moving in a circular path having a radius r, so what will happen if it has a mass m? So we can say that centripetal force will be equal to mv square by the radius of the orbit, right? Where m is the mass of the electron only. Why? Because we are talking all about electron. Now if you talk about the electrostatic force, so this will be 1 by 4 pi epsilon naught charge. So electron and proton both have the same charge, so we can say that E square q1 q2, we can use the formula F is equal to k q1 q2 by r square, right? Divided by r square. So from here what we can rearrange, so if we can rearrange E square by 4 pi epsilon naught into mv square is the radius of the orbit. So we can easily find out the radius of the orbit from here. Now let us talk about the kinetic energy, right? So the kinetic energy K and electrostatic potential energy U. So two types of energies are there, kinetic energy K and electrostatic potential energy U of the electron in hydrogen atom only. We are talking about hydrogen atom. So kinetic energy is equal to half mv square, and this is equal to electrostatic potential energy, that is E square by 8 pi epsilon naught. Why E square by 8 pi square epsilon naught? Because mv square is equal to, see, mv square by r is equal to this one, right? So mv square will be equal to uh, e square by 4 pi epsilon naught into r. So let us do it so that you will able to understand. Mv square by r is equal to 1 by 4 pi epsilon naught into epsilon e square by r square. So r got cancelled out. So from here, and if I will multiply it by half mv square, so this will be multiplied by half, so this will become kinetic energy, and this will become 1 by 8 pi epsilon naught into e square divided by r. So this is the kinetic energy. So I hope you have understood this one. So this is the kinetic energy, right? So kinetic energy, finally we have got a finally we have got kinetic energy as half mv square. This is equal to this, and kinetic this energy. And if you talk about the potential energy, so just now we have understood that potential energy will be equal to q1 q2 by r. So this is a potential energy, right? So we have got two types of energy, kinetic energy and potential energy. Just observe it properly. Kinetic energy, you will have a e square by 8 pi epsilon naught into r. What is potential energy? Potential energy is negative of epsilon naught into 4 pi epsilon naught into r. Why this happens? So just now we have derived this potential energy, right? Whatever kinetic energy will come, so this will get converted into potential energy at all, right? So so this will be the kinetic energy and this will be the potential energy, right? Potential, again I'm telling you, potential energy is equal to k q1 q2 by r. So k means 1 by 4 pi epsilon naught, q1 q2 means charge e square, divided by R. So this is the potential energy, and potential energy will be in a negative, right? So we have got two energies. Now total energy, if we talk about the total energy, so this will be equal to kinetic energy and potential energy. So our kinetic energy is E square by 8 pi epsilon naught into R, and kinetic energy is minus E square by 4 pi epsilon naught R. So when we add this, so we will get this. So finally we have got each and every value. Just try to understand. Kinetic energy is equal to E square by 8 pi epsilon naught into R. Potential energy is equal to E square minus E square by 4 pi epsilon naught into R. And total energy will be equal to minus E square by 8 pi epsilon naught into R. So these three formula is to be memorized while before solving the problems. Now on the basis of this above, we can solve this problem. It is found experimentally that 13.6 electron volt of energy is required to separate hydrogen atom into the proton. It means that it has a 13 point C. This is an atom, this is electron, and it requires how many electron volt of energy to separate them? 13.6 electron volt. It means that the potential energy will be how much? Definitely it has potential energy of minus 13.6 electron volt. Complete the orbital radius and the velocity. So we need to find r as well as velocity. So see here, as we know that total energy is equal to minus 13.6 electron volt, that is this joule, because if you will convert this electron volt into joule, so you need to put the value of electron charge only. Okay, so we have got as a total energy. Now total energy is equal to minus E square by 8 pi epsilon naught, or just now we have studied. So from here we can easily find out R is equal to E square by 8 pi epsilon naught into total energy. So just need to put the values, every values. So if you will put every values, so you will get this one. So always try to use these values. For 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9. So it will be more useful for the easy calculation. Now from here we have got the total energy, right? So from here we can easily find out velocity of the revolving electron. So V is equal to E by root under 4 pi epsilon naught into IMR. So from here if you put each and every values, so you will get velocity is this. So I hope you have understood this. I hope you have understood this problem. In next part I will come up with the next topic. Thank you for watching my videos.